2.3 is on Island Biogeography. The goal for this is to describe island biogeography and its role in evolution. Island biogeography is the study of ecological relationships and distribution of organisms on islands, and also how these organisms, how they fit into their community structures. It's basically, how do species come to inhabit an island? How do they evolve over time? The number of species found in an undisturbed environment is determined by two things: immigration and extinction. And those things are then determined by the distance from the mainland and the size of the new habitat. And to explain how, I'm going to show you a really complicated graph, but don't freak out. We'll unpack it just by a little bit at a time. Well, I know there's a lot going on here. So there's a few different things that this graph is trying to say. It's looking at the distance from the mainland. So in other words, like where are these species ancestors coming from, and the size of the island they're moving to. The blue lines will show the rate or probability of colonization, so the chances that they're going to stay there and continue to pass on their genes, versus the probability of extinction. So, they die out after a few generations. And of course, this doesn't have an axis, but it's like 0 to 100, because it's the rate or probability. And then the bottom line here, the y-axis, is showing the increasing species richness. So in other words, the variety of species that is coming or already exists on that island. Okay, so let's unpack this. Let's say you're really close to the mainland. As with a few species, being close to the mainland means you have a much higher chance of colonizing this island. Makes sense, they don't have to travel far. That's right there. So if you're closer to the mainland, you're going to be more likely to colonize it and stay there than if the mainland is really far away. But then both of these, despite the distance from the mainland, as there are more species on this island, it's less and less likely that you are going to survive. Because, one voice in 1,000. Less likely to be heard. And then over here, we look at the size of the island. So a small island, you're much more likely to become extinct because there's less resources, there's less space for you to, have your population. And so small islands will see a higher probability of extinction than large islands. So where all these lines meet tells us that if you have a small, distant island, you're less likely to have a lot of species. But if you have a large, nearby island, you're going to see a lot more species. So this is like the ideal situation where we're going to have a higher species richness without the chance of, lesser chance of extinction, a higher chance of colonization. Phew, that's a lot. But it's just, trying to fit everything all at once and make it nice and neat and pretty. Essential knowledge number 2, islands have been colonized in the past by new species arriving from elsewhere. So for example, like the Galapagos, the Aleutian Islands in Hawaii, in Alaska, Hawaiian Islands. I mean, duh. I feel like this is kind of obvious, but, just taking it from AP. Essential knowledge 3. This is pretty important. Most island species have evolved to be specialists versus generalists. And that's because islands have very specific sets of resources, very specific food source, territory, other stuff like the amount of water, the type of habitat, the type of, space you can kind of find your way into. So there's not a whole lot of variety in those things. So the species that will have evolved are going to be the ones that have those mutations that allow them to exist in this environment the best. Rather generalists, generalists are more likely to have all sorts of different types of or they can adapt to all sorts of different resources, but if there's only a specific set of resources, they're not as likely to be on this island. That being said, if you have a generalist come to that island, they are adapted to all the things. And so now you get then in the situation where you have the specialist that needs to have this type of food, and this journalist over here comes hopping in or flying in or whatever else they do, swimming in, and they're like, hey man, I can eat all of this. And the specialist is like, no, my food. And journalist is like, ha 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 ha, I win. And in the situations we call them invasive species because they've invaded, they've destroyed everything, and jeopardizes the long-term survival of specialists and can put that species richness and biodiversity of that island at risk. Now it's your turn to describe island biogeography and its role in evolution. The end.